Alright, so in the past videos, we only solved the roots of a quadratic equation by the means of factoring alone. So let's say we have a quadratic, which is x squared plus 5x minus 6 is equal to 0. Okay, now we can see that we can easily factor this into x minus 1 and x plus 6. And of course, we can also see the roots being equal to x is equal to 1 and x is equal to minus 6. There we go. So as you can see, factoring does make solving for the roots faster and easier. But what's going to happen now, let's say if the quadratic that we get isn't a factorable quadratic. Now, some of you might say, well, just use the quadratic formula, which is x is equal to minus b plus minus the square root of b squared minus 4ac all over 2a. And there's nothing wrong with using this formula, but where did this formula even come from anyway? And that is what we're going to learn in this video. It is a method called completing the square. So I'm going to put here by completing a square. So the trick behind this method relies upon the perfect square trinomial. So let me erase this and this. So if you still remember the perfect square trinomial, so if you've listened to your high school math teacher, you might still remember this as the perfect square trinomial, which is quantity of a plus b squared, and that's equal to a squared plus 2ab plus b squared. And don't forget the negative version of that, which is a minus b, quantity of that squared. That's equal to a squared minus 2ab plus b squared. So if you still remember these, then great, because we're going to be using that in this video. So let's say that we now change the coefficient of the middle term, x, into 4 from being 5. So now you can see that this quadratic isn't a factorable quadratic anymore, because you can see the 6 at the right, it doesn't have factors that can add up or subtract into a 4. So no, we cannot factor this. So what we're going to do here is we're going to have to complete the square. So the very first step of this is that you see the 6 right here. We get rid of that by moving to the right side. So I'm going to write that now. So here, I'm going to write x squared plus 4x. And then I'm going to leave a space right there. Because this is negative 6 here, it's going to become positive 6 on the right side. Okay, there we go. So why did we move 6? It's because this 6 doesn't make a perfect square with x squared plus 4. And now, because we want to make the x squared plus 4x into a perfect square, we need to fill in this blank. And what number do we need to fill this blank up with? Can you tell? Well, to find out, we just need to look back at our formula for a perfect square, which is this. So I'm going to use this, the top one, because the sign here is plus and also the sign here is plus. So now we can see that in order to resemble this, the x squared that we have here has to be a squared. So I'm going to put here, this has to be a squared. And the 4x, this has to be 2ab right there. So I'm going to put here 2ab. So if x squared is a squared, then this x right here all by itself must be equal to a. Okay? So I'm going to use another color for this. And then if we know this, then this 4 has to be equal to 2b. Okay. And the number that we need to fill up this blank with is equal to b squared. We need to fill up that blank, that space with b squared. Okay, so what is b squared? Since we know that 4 is equal to 2b, so 4, I'm going to write here, if 4 is equal to 2b, how do we get a b squared out of that? Well, we just divide by 2, and then we square both sides. And what do we get? So on the other side, we're going to get 2. And then here we're going to get b. And we still need to square. And then we get 4 right back. So 4 is equal to the b squared. So we fill this space up with 4. So I'm going to write here 4. And also don't forget the other side. There we go. So let me erase this now, because we're going to need that space. So now the next step is on the right side, we can add up the 6 and the 4. We're going to end up with 10. And this is now a perfect square trinomial. X squared plus 4x plus 4, it now resembles this. So now we can just write that up as x plus 2, quantity of that squared. And there we go. Easy as that. Okay, so what is the next step? Well, we're going to need to get rid of this 2 right here. So how do we get rid of this 2 right here? Well, we need to square root both sides. Okay, so as you can see, the square root and the square here, the 2, they're going to cancel each other out. I'm going to do this. So right here, I'm just going to write x plus 2. And of course, this becomes square root of 10. But don't forget, because we're square rooting, we need to take into account both positive and negative roots of 10. Okay, so there we go. So what is the next step here? Well, we can just move the 2 to the other side. And that becomes negative 2 plus minus square root of 10. So our final answer here is going to be, one root is going to be equal to minus 2 plus square root of 10. And the other one is minus 2 minus square root of 10. And there we go. So the bottom line here is that, let's say you have a polynomial. Then I'm going to write k as the coefficient of x, and then you still need to fill this blank up to complete the square. The bottom line here is that as long as you see x squared all by itself, as you can see, it doesn't have a coefficient right there. You don't see the coefficient if it's 1, right? Then this k is that you can safely divide this by 2, and then you square it to get whatever you need to fill this blank up with. Okay? So this method only works if you don't have a coefficient for x, or coefficient is 1. And that is how you solve for the roots of a quadratic equation by completing the square.